Practice test continued. Number 9 on page 59. Given the graph y equals f of x, sketch the graph of y minus 4 equals 1/4 f of 1/2 x plus 3. So on the left, we have the graph y equals f of x. If we take a look at the equation, the graph y equals f of x is stretched horizontally about the y-axis by a factor of 2. Okay, so let's go here. First one, horizontally about the y-axis by a factor of 2. Stretched vertically by a factor of 1/4. It's reflected in the x-axis and translated, last point, 3 units left, and 4 units up. So you could progress from f of x to graph 1 to show the stretch horizontally about the y-axis by a factor of 2. Then graph 2, you could stretch vertically by a factor of 1/4. Or if you wanted, you could combine 1 and 2. And then 3, draw another graph reflected in the x-axis. And finally, translate 3 units to the left and 4 units up. So your final graph should look like the one on the right, or close to it. 10. Consider the graph of the function y equals f of x. Sketch the graph of the inverse. Well, to the right is the inverse. Explain how the coordinates of key points are transformed. Well, basically to sketch the inverse, we have to find key points. So here's a key point, and the key point is 1 and -3. So to sketch the inverse, we just create the new key point and we interchange the x and y coordinates to get -3, +1. Another key point is -2, 0. So when we interchange those, we get 0, -2, which is another point on our inverse. And finally, we have another key point of 0, 4. So when we interchange the 4 and 0, this is the last key point we need to graph. And we have the graph of our inverse. To explain for B how the coordinates of key points are transformed, well, we'll have to write it out in full sentence form for a diploma. The image points of an inverse are determined by interchanging the x and y coordinates. Of the key points. I'm going to put of the key points. So state any invariant points. Any invariant points lie on the reflection -1, -1.